A very warm welcome to you once again. Thank you for joining. Last time we looked at this network and we built this network on the Cisco packet tracer. What we did last time was a very quick summary is we built these 4 computers, connected to the switches, and connected a router in between. And we configured the router so that routing could take place. We configured the default gateways on the computers so the packet could basically be sent from computer A to the switch to the router, all the way to computer D, and all the way back. So everything worked in this network. That was the last lecture. Please feel free to go back and look at the previous lecture if you want to see the details of how everything was configured. Now, this was done in what is called a real-time mode. What we would like to do today is to look at what is called the simulation mode. So when you have a problem, what you want to do is to simulate this problem, or if you want to troubleshoot, this is a great way to learn how the packet actually flows through the network. So we'll try and look at how the simulation mode works and what information it gives us, right? So I'm going to turn on simulation mode in here. I'm going to go to computer A, and I'm going to go to the desktop over here on computer A on the command prompt, and I'm going to say ipconfig to confirm its IP address, which is 192.168.1.1. Computer D, which happens to be on the other side over here, is 192.168.2.2. So I'm going to ping computer D. Okay, so that's what I would like to do, is to ping computer D from computer A. Okay, so that's what we're planning to do. So I'm going to go here and I'm going to say ping 192.168.2.2, enter. Now, nothing is going to happen here because we haven't really started the simulation. We are in simulation mode. We haven't yet pressed the play button. Okay, you can see everything is static here. Now, when we press the play button, you will see the packet making its way to the switch, and then it's going to be forwarded to the router in computer B. And you can see an X happening over here, and you're getting a reply to the computer A. So what happened here? So let's have a look here. So let's going to pause this here for the moment. We haven't finished the whole process, but let's pause here for a moment and understand what actually happened here. So when we look at the first packet, you could see that the first packet that is being sent here has a source IP address, and these are the 7 layers of the OSI model. Layer 3 is the network layer, right? So you can see the packet information in here, which is kind of very revealing, is that this packet that was sent first, right? This is the information at device computer A. So at device computer A over here, the destination is computer D. What we find here is the source IP is that of the computer A. So this is the IP address of computer A, and the destination is that of computer D. That's where the packet is headed. And this is an ICMP message. Now there is more information in here, but you can see here that the ICMP echo request message has been formed, right? And it has already realized that the destination IP address 192.168.2.2 is not on the same network. Okay. However, it has realized that the default gateway is set. So it realizes, hey, I cannot get to this address, to the computer D directly. I have to send it to the default gateway, which happens to be router 0. Okay. And the second packet over here, now this is computer A realizes, hey, I know that this machine, computer D, does not exist on the same network. So what I will need to do is to create an ARP broadcast. Okay, so you can see a device computer A, source is computer A, but now the destination is a broadcast. You can figure out a broadcast by looking at the destination MAC address. You can see the source MAC address is that of computer A. The destination is FFFF all across. If you see all Fs, basically that's a broadcast MAC address. And the packet is that of ARP. So ARP has this kind of property in which it happens to be a broadcast, and it'll give its source IP address and the IP address for which it's looking for a MAC address. ARP is basically a table that translates IP addresses into MAC addresses. Because it does not have the MAC address of the router, it's basically creating an ARP request. Then the third packet over here, now it is at switch 0. The switch 0 has received this packet. The source is computer A, and there is a broadcast, right? Now, if switch 0 receives on port fast Ethernet 01, it receives this packet. It says, hey, this is a broadcast packet, so I need to send it to all the ports that connect to me. So the ports connected here on switch 0 is fast Ethernet 02, which is computer B, and the gigabit Ethernet 02, which is router 0. Okay, so the switch, having received the packet or the frame at fast Ethernet 01, is going to send an ARP broadcast to all the connected devices. They'll say, hey, I'm looking for this IP address. What's your MAC address? So this is the ARP request, right? It says, hey, I'm looking for a MAC address with this IP for this person here with this IP address. Okay. At device B, computer A, the source is computer A, destination is a broadcast. Basically, computer B is going to ignore this packet because this IP address does not belong to computer B anyways. Right? At the device router 0, the source is computer A and destination is broadcast. Now it realizes, hey, this is for me. Somebody is looking for my MAC address, right? So the inbound was a broadcast. You can see source was the computer A. Destination was a broadcast, but now outbound leaving the router this time is the MAC address of the router, right? So this AB03, which is now the destination, which is computer A, but the source is the MAC address of the router itself, right? So basically, the router is replying to say, hey, I can give you my MAC address. This is my source MAC address. This is my MAC address here, right? And the IP is 192.168.1.254, which is the source IP, which is the router's IP address. Destination is back to computer A. So basically here, computer A is replying, I would say router 0 is replying to computer A, giving it its own MAC address because that's what it's looking for. At this point in time, now at device switch 0, okay, nothing has changed in that sense because now the switch is just going to forward the packet over that it has received from gigabit Ethernet 02 back to fast Ethernet 01, which is computer A. And at this point, the computer A receives the packet, right? So now it realizes that, hey, I have received a packet from the router with this MAC address and this IP address, and this is its own MAC address and destination IP address. Now we can continue the simulation because now that packet is sitting in here. So now computer A knows the MAC address of the router 0. If we continue on the simulation here, you can see the packet is making its way over to the switch and then to the router. It realizes that router is not where it is destined for. So now you can see the packet has been forwarded to the switch and to both the computers. So this is the ARP request. It's looking for the MAC address of computer D, and it's making its way back here. So let's pause this for one moment here. So we finished here with the communication process and then the router itself. Okay, so let's go back just a moment over here. At the device router A, the source was A, destination was the same over here. The gigabit Ethernet port 00, which is this port, had received the frame, right? At this point in time, the ARP process now is going to reconstruct itself, requesting for the MAC address of the target IP address, because now you can see this packet has a source MAC address, which is that of the router itself on this other interface. The destination is a broadcast because it says, hey, I know my IP, but I'm looking for the MAC address of the destination machine, which is computer D. Right, so now we are at this stage. At this stage, we are now at switch number 1. Switch number 1 receives the packet at gigabit Ethernet 02 on this side here. Okay, and now as you can see, the frame itself has it's a broadcast frame. It's an ARP broadcast, right? The source is that of the router 0, and the destination is a broadcast, right? And basically the source IP is that of the router on this other side, which is 192.168.2.254, and the destination is that of computer D, which is 192.168.2.2. So this is what the switch receives on gigabit Ethernet 02. It's going to say, hey, I have a broadcast, so I need to forward this broadcast to all the devices connected to me, which is fast Ethernet 01, which is computer C, and fast Ethernet 02, which is computer D. When it forwards this broadcast, obviously computer C is going to receive that at device computer C. It will ignore it because it will realize, hey, the broadcast is not looking for me. This is not my IP address. However, computer D is going to receive the same broadcast. I'll say, hey, looks like this computer is looking for me. Yeah. If you remember the Rick Ashley song, I don't know, is it me you're looking for? Oh, it's not Rick Ashley. It's Lionel Richie. Hello, is it me you're looking for? Okay, so here we are. Okay, something to laugh about, I guess. I mixed up there. Rick Ashley and Lionel Richie. Oh, those days were nice in England when these albums came out, both of them. Alrighty, anyways, those are the mid-80s. Alrighty, so basically the computer D receives the broadcast and replies back to the broadcast with its own MAC address as being the source MAC address, destination being the MAC address of the router. So this is an ARP packet reply with the source address coming from computer D, destination being the router itself. So now the reply is going back to the router to say, hey, I'll give you my MAC address so you can forward me the packet that belongs to me, right? So here is now a device switch 1. Switch 1 is going to receive this information on port fast Ethernet 02. It will forward the information to the router to say, hey, you're looking for this information, I'm going to send it back to you, right? Which is 4 gigabit Ethernet 02 is going to say, hey, you're looking for a MAC address of computer D? Here we go. This is the MAC address of computer D. Okay. What's going to happen next? The router 0 is going to receive this packet, right? So now I know the MAC address of computer D. Okay. And this was its IP address, right? We can continue on this simulation now. So now the router has enough information to now forward this packet to its destination. right? So eventually the packet will get to computer D. Okay, so that's it for today. Thank you so much for watching. Have a wonderful, wonderful evening. Take care.